My name is Tessa Terpstra. I'm with the Netherlands Ministry of Foreign Affairs, and I'm the regional envoy for water and energy security. I basically focus on the nexus, water, energy, food, and climate change here in the MENA region. I'm really happy to be moderating this session, and we have some Dutch experts here in the water field, and also our Jordanian partners in the water field. I would like to introduce to you some of the expertise we have to share under our UNESCO IHE program and with the VU Free University of Amsterdam. So about the UNESCO IHE project, you can see it here. It has different components which we will all introduce you to through our different presentations. There's a water accounting projects on desalination, wastewater treatment. There's the faecal sludge treatment or projects that we're doing. And there is a regional cooperation between water institutes here in the region. And we will go through these projects one by one. So I suggest that we have 6 presentations, which is quite a lot. We'll have 10 minutes per presentation. So we will have 3 presentations, then have some Q&A. You can ask questions, and then the next 3, and then again we'll have Q&A. I just heard that the translators need to leave at 5. So if we continue beyond that, we'll have to do with English and Arabic, of course, and we can translate as we go. So we have 3 presentations on more specific technologies and 3 presentations on more analysis in water accounting and water balancing and economic models. So we will start with the more technology presentations, and then have the Q&A, and then we'll go on with the more analysis presentations. So I would like to ask Mona to present first. Mona is with the Water Authority of Jordan, Ministry of Water and Irrigation, and you will tell us something about desalination, right?
Good afternoon. My name is Mona Gharybeh. I work as the manager for the Desalination Department in Water Authority of Jordan. So, as Tessa said, that I want to talk about the desalination and the future urban water supplies in Jordan. As you can see here about the presentation, I will introduce the water sector organization in Jordan and some facts about the water scarcity. Then I will talk about the water sector challenges and what strategies that we have applied. And then I will talk about one of these strategies, the desalination in Jordan. Then how the SCARS project hit some of these challenges. As you can see here, the chart shows the water sector, the organization chart of the water sector in Jordan. You can see the minister and the 3 entities or utilities. We have the Water Authority of Jordan, the Ministry of Water and Irrigation, and the Jordan Valley. All of us knows that we are the second poorest country in the world in availability of water resources. We have only less than 130 liters per capita per share and for water supply. Of course, this position came with a lot of challenges that we face. The first one is the limited renewable water resources, and the second is with the abnormal growth in population that in addition to the climate change and the effect of this on the renewable water resources, and then the limited energy resources. First of all, the first challenge, which is the limited renewable water resources, we have only 61% of the total supply is supplied from groundwater aquifers. We have 12 aquifers. 6 of these aquifers are over-abstracted. 27 of the water resources is from Yarmouk and Jordan River, the surface water. And we have 20% less historical flow from this surface water, and it is decreasing by time. In addition, that we have only 1/3 of our allocation from this source. This source is shared with other parties, with other countries, and from Syria and the Palestine Treaty. In addition, we have the rest of this percentage, which is about 12% that we use from wastewater reuse. And this is used for restricted irrigation. As you can see here, the census in 2015, we have 9.5 population, and we have 1.3 Syrian. So this put a lot of pressure on our water resources and the systems in Jordan, all over the kingdom. Of course, the climate change, we know the effect of climate change. We have less rainfall distribution all over the country, and this affects the groundwater recharge. And we have over-abstraction from this groundwater. This causes a decrease in the static water level and deterioration in water quality. Of course, the limited energy resources do affect our abstraction of water, and even to apply any other strategies. We need the energy for transporting the water, available water from Jordan Valley, which is, we have like minus 400 meter below the sea level, and even in the north we had minus to about 200. So we need to pump the water from a very low level up to Amman or Gharybeh city by 1,000 meter. So this put another pressure on the water sector in Jordan. Of course, the water sector have applied a lot of strategies in order to meet these challenges. The first one is with using the non-renewable water through the DC project. And we have also constructed our plans for new dams and water harvesting in all over the kingdom. Also, we have another additional projects in non-revenue water in fixing the leakages and illegal uses. In addition, to focus more about wastewater reuse, to use it in agriculture for restricted irrigation. And the final resort or the strategy that we can apply is the desalination, either for brackish water or seawater. You can see here the project of DC, the 350 kilometers pipeline. Here we have the biggest wastewater treatment plant, Samra, that is used for reuse in agriculture. So applying all these strategies, they didn't fill the gap between supply and demand. So we have to think with another innovations and non-conventional resources. And we can see that desalination is one of these non-conventional innovations. Desalination in Jordan have been applied since 2000, and we have a lot of desalination projects. The brackish water reverse osmosis systems. We have about 23 plants, and that can produce 88.5 MCM per year. Another thing is that we can use also the seawater reverse osmosis system, And we have the first seawater system or plant in Aqaba by joint venture with Kimapco company. And this is still under construction. And we hope that the next month we can put it in operation. Of course, all these strategies will never, again, fill the gap between supply and demand. So we need the final solution that we think here in the water sector about the Red Dead Sea project. We need to desalinate the seawater through this project. You can see an example of the biggest brackish water. I think it's not even in Jordan, also in the region. Zara Ma'in Mujib and the desalination plant and the conveyance system. Here, the second biggest in Jordan, Abu Ziran. You can see that most of these treatment plants are in the Jordan Valley. And we have the final solution that we believe that it will solve all our problems and provide a sustainable solution to fill or to offset the water deficit in the region. In addition, this project will save the Dead Sea from environmental degradation. Of course, application of such technology have its own challenges. The first one is with power consumption. As I said before, that these aquifers, the brackish aquifers, or even the sea, is far away from the big cities, from Amman and from Irbid, from Zarqa. So we need power consumption in order to transport the product from these plants. In addition, that we don't have any seawater desalination plant in the country, so we have no knowledge. We need to build knowledge about this technology. For brackish water desalination plants, we have plenty of challenges. One of them is the lack of skilled operators. These plants are scattered in rural areas, so we cannot, it's a challenge to find skilled people, skilled operators to operate these treatment plants in an efficient way. In addition, we have some poor design in pre-treatment, and this will result in low performance, low quantities that can be produced from these treatment plants. In addition to the energy cost and the high operational cost for the consumables and the membranes, plus the energy. So we came with the SCARS project that will hit some of these the challenges and the strategies. The first one, yeah. This project is funded by the Ministry of Foreign Affairs and implemented by UNESCO IHE, where the Jordanian partners that can be seen here in the banner. You can see the logos at in the top. And the main objective is to, for the capacity building, to hit or to strengthen the capacity building of the employees in the water sector organizations. It's not only WAJ, it's also JVA, the universities, and other entities, utilities. So focusing on capacity building through this project came with 3 training courses. As you can see here, the topics of these training courses, in addition to conduct some research on biofouling potential of the Red Dead Sea that we don't have any studies about the biofouling in the Red Sea in the Jordanian side. It's through MSc students and PhD. You can see here one of these training courses that have been conducted last week. In addition to these training courses, we have a project of re-innovation of one of these treatment plants to improve the design of the pre-treatment and to reduce the consumption of energy. In that way, we can operate the plant efficiently, so we have less consumables and we can increase the membrane lifetime. So we can save some of these expenses. You can see here one of the site visits during this project. And thank you all.
Thanks for sharing with us this broad project. Sorry.
It's a challenge in these 10 minutes.
Yeah, you're perfect on time.
That's
Thanks
why
for sharing this broad project with us. Are there any burning questions, or shall we go to the next session or the next presentation, and then you can ask your questions later on. But do feel free to ask questions if you have during the session.
Yeah.
I'm Dr. Qasim Al-Jabiru from Oman. I would like to know the salinity of the brackish water, which is going to be desalinated.
Yeah, we have like 4 aquifers with brackish water, and it ranges from 2,000 ppm up to 8,000. It depends on the location of that water. So the treatment plant that Abu Zigan is the highest, that location, and Zara Ma'in is the lowest, about 2,000. The 2 examples of the high and low salinity. You're welcome.
Okay, so now we'll move on to Dr. Almanaseer. Naser, please. And this is about decentralized wastewater treatment.
Keep talking. Sorry. Okay. Thank you, Tessa. Good afternoon, ladies and gentlemen. I really would like to welcome you to this session. Maybe I take a minute to introduce a concept of the DUPC2 committee. It is an initiative by UNESCO IHE, and I am presenting it as a regional committee member for UNESCO IHE in the Middle East. The committee is sponsoring a number of projects in the region. A number of these projects is on the banner, and some projects are in the assessment phase. We, the committee, hope to help the region in general to come up with some solutions for water challenges in the region. So I would encourage you to go to the UPC2 committee member website. Just Google it and look at it and see if we can help you in solving some potential problems. Also, the committee would love to see some proposals sponsoring youth or related water problem related to youth and so on. So today I will talk about decentralization, decentralized wastewater management in Jordan. One of the alternatives, one of the strategies to cope up with the water stresses in the region. So basically, how I want to talk about this, maybe I can talk about the research station, the activities that we do in decentralization, and this is the way probably I can quickly explain to you how we solve the problem. So basically, I come from Al-Balqa Applied University, a professor in civil engineering. I have a research in decentralization. This research ended up with a research station we built in collaboration with UFZ in Germany and other partners around Europe. The research station has a number of technologies, decentralized wastewater management technologies. We treat wastewater in different technologies, and we monitor the in and the out, and we evaluate the alternatives to recommend these technologies to be used in the region. So these technologies quickly, a number of technologies ranged from modified septic tank to SPR to wetland to membrane filters and so on. So the idea of this presentation is not to introduce the technologies itself, but to have an idea about the concept. So also we currently are constructing another two technologies. These technologies are monitored, as I mentioned, once a month, in and out for different biological and chemical parameters. In addition to these 10 units on site, we also constructed 10 units for people at homes, in companies, at schools, and also we monitor this. This effort is about 8 years now, and eventually we came up with a decentralized wastewater strategy. And that is something we did in collaboration with the Ministry of Water and Irrigation, and finally they approved it. So let me just go through some of the results. So we have technologies, we examine in, we examine out, and we measure the performance of these technologies. So if you look at this shape or figure, you can see the numbers, the 95, 7, 98, 97. This is the efficiency of different technologies on the site, in the research station. So really a big deal of efficiency that is, we are proud of it. And also, we look at the BOD, the efficiency from BOD perspective, for the 10 stations in the region. Those 10 stations you can see on the x-axis, IS, SH, FH. Those stations are installed at homes to help people, to help farmers, to help schools, and we keep monitoring them. The blue long bar is the standards. So we are the inflow. So the standard is the green, and the red is the outflow. So these 10 stations are beating the standards in all BOD values, also in COD values. To the right, you can see the efficiency. We measure the efficiency by comparing the COD of the inlet and the COD of the effluent, the outlet. So it is very efficient to use these technologies for treatment and also for reuse. So what do we need to do with this? So this is something we need to promote. We need to use as a strategy to cope up with those challenges, with the water stresses and so on. So to do this, we needed some people who are skillful, who